Hi everyone, welcome to the Marathon webinar series. Today we will talk about ecological risk assessment of the nearshore deepwater fisheries of the Mesoamerican region with Ivy Barrymore from MarAlliance. A few notes and rules. If you need interpretation, please in the Zoom control, click on interpretation. Click on the language you want to hear. And if you want to hear only the interpreted language, click on mute original audio. Si necesitan interpretación, escogen el idioma que desean escuchar y silencie el audio original. So, a few basic rules. We encourage a space for learning and respect. Please disable your microphones and camera during the webinar. Write your full name, country, and organization in the chat. And if you please can write your question in the Zoom chat or raise your hand. If you are participating via Facebook Live, you can submit your question through the Facebook comment section. Your question will be transferred and answered by the speaker at the end of the presentation. Please remember that the opinion expressed in the webinars are the sole responsibility of the speaker and do not necessarily represent the opinion or position of Marathon. So today we have Dr. Ivy E. Barrymore. She is the science coordinator for MarAlliance. She graduated from Florida State University in 2001 with a Bachelor of Science in Biological Sciences. She began career in 2001 as a biological technician with the National Marine Fisheries Service. She earned also a master's degree from the University of Florida in 2006. She works also to MFS as a fishery observer coordinator and then also became a fishery biologist. Then moved to Belize in 2013 to work as technical coordinator for MarAlliance, leading deepwater fisheries research in the Mar. She also completed her PhD with the University of Exeter, which took place between 2019 and 2024, focusing on deepwater fisheries. She now supports research and data analysis across MarAlliance country program. Please say hi to Ivy and welcome her to our 32nd webinar at Marathon. Ivy, welcome. Just a reminder for all our participants, you can find information about the Mesoamerican Reef Fund in all our social media. You can see here what we have. And if you have missed any webinar, previous webinar, you can find it in our website. So Ivy, welcome.
Thank you. Thanks, Elisa. I'm very glad to be here. Let me start my presentation.
Yes, thank you so much.
Is that on the first slide?
Yes, just a reminder to all the participants, Ivy, if you, everyone can write their name, country, and organization in the chat. And please leave your audio and camera off to avoid distraction. And if you need any questions, or if you have any questions, you can raise your hand and or write the questions in the chat. Sorry, Ivy, for this. You can go ahead. Thank you.
Okay, thanks very much. And thank you everyone for being here. As Elisa said, my name is Ivy, and I'll be presenting an ecological risk assessment for the nearshore deepwater fisheries of the Mesoamerican region. This presentation represents the final work of my PhD dissertation with the University of Exeter, and something that my bio did not mention is that I'm actually in Honduras now. I've been here for the last 6 years. And so that's where I've been basically based out of conducting this research for the last few years. Something else is that the presentation, I'm speaking in English, but the presentation slides mostly will be in Spanish, just to let you know how to expect to see things. So when we think about fisheries management in general, traditional strategies such as stock assessments often come to mind. However, these methods can be difficult to implement in low and middle income countries, especially in tropical regions, and as you probably know, throughout the Mesoamerican region. This is especially true for small scale artisanal fisheries where we don't have very much data. And because of the many difficulties associated with traditional management strategies in our region and the accelerating decline of fish stocks, the changes from the climate, habitat loss, we really need to try a different approach to fisheries management that takes into account our situation on the ground and the realities. For example, single species stock assessment, which is considered the gold standard of fisheries assessments, are not really very realistic for many of these fisheries because there's a lack of, first of all, species-specific data and time series data, so data that are collected regularly over a long period of time. And these are the data that are needed for these types of assessments. Also, in many cases, the landing sites are not centralized, making it more difficult to monitor the total landings in the country. Management strategy evaluation, which has become a popular tool in several countries, including the United States and Australia, is also not really very feasible, mostly due to a lack of capacity for reactive management and evaluation. On the other hand, ecological risk assessment, also called ERA, is a very successful tool for evaluating the relative vulnerability of fish stocks to overfishing. Ecological risk assessment is based on what is known as productivity susceptibility analysis, or PSA. There are a lot of acronyms that are going to go on. This shows my background with US fisheries. US government loves acronyms. Anything that can be put into small letters is done. This takes into account the species or the stock's biological productivity in relation to its susceptibility to fishing. The good thing about the productivity susceptibility approach is that it can be modified to suit the needs of the user and the data that are available. So it can be qualitative if you don't really have very much information available, or quantitative if you have more data. It's also adaptable, meaning that attributes can be added or reduced, again, depending on the needs of the user, but also the data that are available. Because of its flexibility, the use of ecological risk assessment has really proliferated in recent years. These are just some examples of some recent papers that have come out in the last few years. So examples include what's known as this M-risk, or which takes into account management, and this was applied mostly to sharks in this example. Other recent papers have incorporated traditional ecological knowledge by incorporating information from fishers. And the ecological risk assessment approach has been applied across several taxa and fisheries across the world. So today I will be talking about the deep water fisheries of the Western Caribbean Sea. As with most of the region's fisheries, this is mostly a small scale artisanal fishery. There is a semi-industrial fleet that does operate in Honduras out of the Mosquito Keys, or out of the Bay Islands within the Mosquito Keys. But for the most part, this is a small scale fishery. And the landings are generally unreported. For the most part, the fish captured are for local use, meaning that they're not exported. Again, there are some exceptions. There are a few that are exported in Honduras, but for the most part, these are local use. And one important thing to note for this fishery is that these fish do not survive capture. They are deep water species. You can't just throw them back because they don't survive. And I also want to point out that the habitat where they live is also very limited. So in this slide, this blue band that stretches along here, I mentioned that the title of the presentation is the nearshore deepwater fisheries, and you can see very much that this is nearshore. So this represents the available habitat where these species can live from about 100 to 500 meters. So you can see that it's a very narrow band that stretches along. It's not a lot of available habitat, and these fish don't really have anywhere to go to escape the fishery. I mentioned that this is the culmination of a lot of long period of work. So about a decade ago, we started in 2015. We did some surveys with fishers, 2015 and 2016, to try to get an idea of what the fishery looks like, what the differences are from country to country in the Mesoamerican region. And so I'm not going to go into all of the results here, but one of the main things that I want to point out that has relevance to the presentation today is this slide here, which is we asked the fishers how long they had been participating in the deep water fishery. So the country's colors correspond here. So Belize is green, Honduras is blue, Mexico is red, Guatemala is orange. And what you see here is that at least around a decade ago, most of the fishers in the deep water fishery in Belize had only been fishing for 5 to 10 years in this fishery. So it's a very young fishery. People have not been participating in very long. It's also a much smaller fishery just because there are a lot fewer people in the fishery. Honduras, on the other hand, has the longest history of deep water fishing in the region, with both young people and older people participating in this fishery. The deepwater fishery is mostly targeting snappers and groupers. For today, I will focus on 10 species that are the most often encountered or targeted in the fishery. It also happens to be the 10 species that we have the most data available for. And these include 6 snappers, 3 groupers, and 1 jack. So the 6 snappers are generally called red snappers with the exception of the black snappers. So we have the black snapper, the black fin snapper. This is the cardinal snapper. In Belize, it's called the champagne snapper. Everywhere else, it's called about 15 different names, depending on where you are, which island, which language you're speaking. But it is the cardinal snapper. The queen snapper, which is also called longtail or satin. And this is the silk snapper, which is mostly called yellow eye snapper, both in English and in Spanish, and vermilion snapper, which is mostly just called red snapper. Here we have the misty or mystic grouper, the snowy grouper, which is mostly called the long spine snapper because it has these nice long spines here, the yellow edge grouper, and then the 1 jack that we see often. It's called salmon often, but this is the Almaco jack. So I mentioned that we have been conducting research on this fishery for quite a while. So for the last decade, we have been investigating the life history and the abundance and distribution of these species. And what we have found is that overall, these species have several characteristics in common that make them especially vulnerable to overfishing. We found that most species have a surprisingly long lifespan, with some of the snappers living for more than 60 years. This is especially true for the cardinal snapper, the champagne snapper. And then some of the groupers we know can live to be more than 80 years old, very, very old. However, we still have quite a lot to learn about these species. We do know that groupers, especially throughout the world, are often the first species that are extirpated or overfished. This is because of their general life history biology. They tend to be very big, and this is especially true for the deep water groupers. They are not as widely spread as the snappers, and they're also very aggressive to bait. So they, if something comes in their territory, they bite it. And that makes them easier to fish out of their preferred habitats. And again, something to keep in mind is that when these fish are captured, we cannot throw them back. From our study on the abundance and distribution of this species, we found that the snappers, for the most part, were very widely distributed with a couple of exceptions, such as the vermilion and the black snapper. As I mentioned, groupers are less abundant, and they're also more irregular. So they're patchy in their distribution. They tend to occur in one area, but not over a broad area. And what we found overall was that the fish in Belize were also not only more abundant, but they were also larger than those in Honduras. And that goes back to that original slide where I showed that the fishery in Belize, it's a younger fishery than the more established fishery in Honduras. And we also found that the deep sea fisheries in the Bay Islands are likely overfished. And that's not surprising because it is probably the closest fishery, closest island to deep sea fisheries. So for instance, you can see in these images, the top photo, while it's not something you would expect to see every single time you drop a line, it's also not uncommon to catch this size and these types of fish. But in the Bay Islands, which is what you see on the bottom, this is actually very infrequent. We did not catch this species very often, but that's about the biggest of the queen snapper that we encountered in the Bay Islands. So again, this was a very quick summary of a decade of research. We do have a couple of papers that are out that I think we'll be sharing along with the information for this webinar, but it's also available on the MarAlliance website. And we have summaries in English and Spanish. So with that background in mind, the objective of the talk today is to talk about and present the results of our ecological risk assessment for the effects of fishing and management. And we have another acronym, ERAFM, in English. And this was for the 10 species that I talked about before, the deepwater species in the Mesoamerican region. A secondary objective today for today to present was to develop a user-friendly, online, freely available toolkit that is adaptable and can provide tailored automated recommendations to managers, to fishers, or other interested parties based on the data that are input. And then finally, I wanted to test out the flexibility of this toolkit to assess a range of species and fisheries and management strategies, just to see if this toolkit is actually applicable to other species that are not deepwater fisheries, in the deepwater fishery. To accomplish this, I put together a rather large data set that included all of the biological and fishery attributes for these species based on the research that we have conducted throughout this project. So the ecological risk assessment for fisheries and management, ERAFM, was based on the productivity susceptibility analysis structure, and it included a total of 7 biological attributes and 6 fishery attributes, and also included a third axis here that was for management, and that was an additional 5 attributes. And we also include a measure of uncertainty, which I will describe in a minute. And then we also calculated this measure of vulnerabilities, or our vulnerability score, which is based on the overall risk from the biological risk, the fishery risk, and the management risk. So this is a very big table, and it is in English, so I do apologize. Nobody really likes to stare at tables and presentations, but I just wanted to show how the scores are calculated. So the first section at the top are the biological indicators, such as the age at maturity, maximum size, and the trophic levels. So highly productive species that don't get to be very big, that grow very fast, have a high productivity score, which means that they are, at less risk. So a lower number equals less risk. The low productivity species that get to be very big, that have late maturity, have a higher score, which makes them gives them a higher risk score. For the fishery attributes, those included the overlap of the species with the fishery, the gear selectivity, and ease of access by fishers, for example. And again, those fish that are highly susceptible to the fishery have a higher risk score, so they would get a 3. Lower susceptibility gets closer to a 1. And then we have obviously the medium susceptibility is score of 2. So for each of these categories, each of these attributes gets a score, and then we take the average of that score for the overall risk. For the management attributes, we took into account whether landings are recorded, if there are management measures are in place, and the level of IUU fishing. And again, highly managed has a low score, low management has a high risk score. And then I also mentioned the uncertainty that we take into account here. And this is based on how sure we are of the information that was input. So if it was something that was measured or that came from the literature of the same region, then we are very confident in our estimates here. So it gets a low uncertainty or high confidence, and that gets confusing. I try to stick to one or the other. Whereas if we don't know as much about this, or we're kind of guessing based on anecdotal information, then that would have a low confidence score, which would put it at a higher risk. So data that are unknown or data with high uncertainty are scored automatically as a high risk. And this makes the estimates more conservative, but it also means that these scores can be improved as more information is gathered. And to familiarize you with the output, this is how the results of the assessment are presented. Productivity is on the x-axis and susceptibility is on the y-axis. Then we have this management third axis on the right-hand side. So anything that's closer, again, to that 1 score is going to be in this low risk quadrant. And then we have the high risk quadrant, which is where you don't want your species to be. Again, the species that are scored on this axis tend to be species that have low biological productivity and are highly susceptible to fishing. So for management, those that get a score closer to a 3 that are undermanaged would be up here, and those that are highly managed would be down here. So we want to be in the green. The second objective for today was to describe the risk assessment toolkit that is available online. And this is meant to enable others to perform these types of assessments based on the best data that is available. This online toolkit was developed in Google Sheets, and it will be freely available online. It is actually now freely available. It provides automatic recommendations for your inputs based for the 10 species that we have evaluated. And it also produces automated recommendations for research and management based on the data that you input into it. It does operate both in English and in Spanish. And again, it includes those measures of uncertainty that I described previously. And you can also complete this form for any species. It doesn't have to be one of the 10 species here if you are familiar with the parameters, and I will describe that a little bit more in detail in a couple of slides. And so now we will get into the results. So here are the results of the assessment, the risk assessment for the 10 species of deepwater fishes. So I'll overlay their images with there so you don't have to look at try to match up all of the little symbols with the guide. If you were looking through the previous part of this presentation, you might not be surprised to see that all of the species were pretty much in the unhappy quadrant. There are all species that are considered to be highly vulnerable to overexploitation, and all of them had this risk score that was above this threshold that puts them at a high risk category. So they're all in this high risk quadrant, and that means that they are all highly vulnerable to overexploitation because of low productivity and high susceptibility to overfishing. However, the silk snapper or the yellow eye snapper sort of ekes out into a slightly less high risk category here. And it's not actually because it's necessarily less vulnerable or has different life history characteristics. It is actually because we have more data available for the species than any of the other ones. This is the only species that has published information on the genetic connectivity. So we were able to input that. And even though it wasn't really great news for the paper that was put out, there was just enough information in there to take the uncertainty down to eke it into a slightly lower risk category. And then you can see this also the size of the symbols. The bigger the symbol, the higher the uncertainty or the less certain we are about these parameters. So there's really not very much information available for the black snapper. It has a very big dot. But you can see the small dot here for the yellow eye snapper means that we were pretty confident about our estimates here. We have a lot of good data. You'll also notice that as expected, the groupers are even further into that quadrant, into the corner of that quadrant there. Again, these are highly vulnerable species. They get to be very old. They are slow growing. They're very big. So that is exactly where we would expect them to be. So just briefly as an overview, we found that the risk assessment indicated that all of the deep water species in this fishery were highly vulnerable to overexploitation. They have lower biological productivity coupled with high risks from capture. And it is clear from the previous work that we've done showing that the deep water fishery in Honduras, showing that there's a lot of overexploitation and being less abundant, that we need to put in some measures of management to preserve the fishery. These could be anything from closed seasons during the spawning months or strengthening of existing MPA structures. For example, here in the Bay Islands, the protected areas do not extend to the seafloor. They only go to 60 meters. So we could work within the existing structure of marine protected areas to help fertilize these protections simply by extending them to the habitats where these species live. We also really do need to have a closer look at the recreational fishery. In many cases, these are people who are going out either with guests or alone. They have a little bit of expendable money. They've got cell phone apps that show them where these banks are. They've got depth sounders. They've got these electric reels. And a lot of times they're going for trophy fish. And a nice trophy fish, is a giant grouper. But unfortunately, these groupers that they're catching may be more than 100 years old. And so that is not something that we would consider to be a sustainable fishery. And so, of course, also our work is never done. And as we see from the big uncertainty estimates that we have around some of our parameters, we need more targeted biological research for a lot of these species to fill in our data gaps. Another objective of the study was to test it out to see how it performed for other groups. So I applied this assessment to a variety of species from different regions, from different management strategies and life history characteristics to determine how well this risk assessment performed. And overall, I was very happy actually with the way that it performed. The results and the recommendations were similar to those that were from published information. So these are, I believe, 12 species, and all of these species had some kind of either a risk assessment or a stock assessment performed, and there was some kind of recommendations for them. So for instance, the red snapper, this is from the US Gulf of Mexico, and it is in this higher risk category. Not surprising, it has a lot of similar characteristics to the species that we evaluated for the deep water. But you'll see here, it actually falls into the highly managed category. So in the US, this is one of the most highly managed species probably in the world. And that makes sense because it is a highly vulnerable species that it needs a lot of management. And it's also from the US. They, at least until recently, had the capacity to do that. This blackfin tuna, that's a fishery from Brazil, and it mostly is higher susceptibility because of a lack of management, but it's a fast-growing species, so it's not as necessarily in this high-risk category. Yellowfin tuna has higher productivity, but it's more susceptible to the fishery. And then we can see things like Pacific bluefin tuna, blue marlin, they fall into a slightly lower productivity, but lower risk biologically. And so finally, now I will talk about our open access toolkit for conducting your own ecological risk assessment. So I will go through the online tool to show how it works and how it might be useful to you or other interested parties. So when you first go to the landing page, you have here the guide that tells you step by step what you need to do. So you'll essentially be working within 2 of these spreadsheets. The first one is the scorecard, which is here, and the second one are the instructions for the dashboard, which is here. And so after you read the guide, you move on to the scorecard, which is screenshot here. So you can see that it says to start here, and you input your region, and then you input the species that you want to evaluate, and it's hidden here, but then it automatically populates these suggestions. So what I'm going to do now is have a little video that will take you through filling out this form and then looking at how the results go. So you come to the page and you want to start, you select your region. In this case, we're going to use Honduras. And then you look for your species, but they're only in scientific names and you may not know the scientific name. So we do have a visual guide for the 10 species. We want to look at the blackfin snapper, which is Janus buchanella. So now we know what the species name is. And yep, there it is. That's the right guy. So now we have all of our indicators that are our parameters that are suggested on the left-hand side. And this video, I'm hoping it's going smoothly for you. It's just going to show that we're going to fill in the parameters based on the suggestions. So now if you are have any other information, or for instance, if you're working within a smaller region or an MPA, you may want to change these parameters based on the best available information. So again, these are just, it's a guide, it's meant to give you information. You don't have to take the recommendations that are on the left. So now you can see as we're going along that it's giving us a risk level. It's giving us the score. So we have overall, this is coming out as a medium risk, but with low uncertainty. Again, confusing, but that means that we're pretty confident in this estimate. Now we're going through the fishery indicators. And so from this, the parameters that we put in here, you can see that it's coming out to be a high risk level. But again, we have really good information on that. So we're pretty confident in that. And then finally, with the management, we don't really have, there's no management here in the country really, and there's not much available habitat that is covered by MPAs. So unsurprisingly, our risk is going to be considered high. Now it's going to tell us to go to the dashboard to see the results. So now that we've put this in, we have, I'm just going to pause the video really quick. On the left-hand side, this gives us basically a resume or just a generalization of what we put in there. So it's telling us that the biological risk is medium, the fishery risk is high, and the management risk is high, but that we're pretty confident in most of these parameters. And then we have the little gas gauge thing that puts this at an unmanaged fishery. So if we scroll over now to the right a little bit, now we have our recommendations. So now we have some, it shows the confidence that we have in all of these, and it gives us recommendations. This one is a resume, basically, that just tells you the inputs that you put into there. So when you are finished with this, you can go back and see why you're getting the results that you're getting. And then finally, if you're a biologist or you need to conduct some research and you want to know where the research is, those are the recommendations there. So this is what it looks like when you go to print it out or to save it as a PDF. So it gives you all of these different versions in a PDF. And then this is going to pause on this last one. So I just wanted to point out this last slide. These are the recommendations for sampling. So for instance, if we don't have any genetic information on the blackfin snapper. And so the recommendation is that you should probably conduct some genetic research for this species. And then it gives a recommendation that is a little bit more specific. So if you do want to conduct a study for genetics, you need at least 30 samples per locality. So very simple, but but somewhat specific recommendations that I believe are practical. Oh, okay. So now that we've run through the whole thing, I'm going to just talk about a couple of things. I mentioned before that you can use this toolkit for any species. So in this case, if you have a different fishery or a different species or something else and you just want to use the toolkit, this shows you what it looks like. This has changed a little bit since I made this screenshot, but essentially in red here, you see basically you just don't get any recommendations. So you do need to have some familiarity with your species, the fishery, and the management, but you can just go in and select other, and it's going to tell you that this is a user-defined assessment. And so again, but keeping in mind that the recommendations are just that, they're recommendations. So even for the species where we have a lot of information, you can change the parameters. So for instance, if you are a manager of an MPA and you just got 3 new boats and a fuel budget, and you know that you actually have better management now than what the recommended parameters are, you can go in and adjust that. And we've seen before that adding more information to this can give you not only more targeted recommendations, but it also can take your fish a little bit out of the higher risk category. So overall, the goal of the online toolkit is to be a feedback mechanism for any of the users. For managers, a lot of times it can be really overwhelming and difficult to know where you need to start when you have limited funding and you have limited resources, and someone says, we need to do an evaluation of the fishery, or we need to know what's going on here. And so this toolkit is meant to give you basically a starting place. So you can fill in all the available information, and then hopefully the recommendations that you get from this are something that you can then implement, that can be used. The recommendations are based on here. So our recommendations for research are based on the uncertainty. So here I have it as confidence because again, it gets really confusing talking about uncertainty. But here, so for instance, the risk is high because we don't have any information on the genetics. So the recommendation is that you need to do genetic analysis, and that's based on the fact that we just don't have any information. So one of the things about this toolkit is that it's not going to tell you to do something that where you have good data. So if you know the maximum age for a species, it's not going to tell you to go out and conduct an age and growth study because nobody's got time or money for that, right? So if you have good information, it's not going to recommend that. And in this case, for the fishery attributes, if you have, this was based more on the risk than on on your confidence. So if you have a high demand, it's going to recommend that you have closed seasons for the fishery. And that, so it's considering limited access based on if you have a fishery that's highly susceptible to the fishery by region. And so we have been testing this out, and we have found that it is flexible and it's responsive to improvements through increased data. But remember that because we are assessing the risk and the uncertainty, it's going to be more conservative than other estimates. But I think that is something that is important because when you don't know, it's better to be more conservative to automatically, go for the assumption that the risk is high rather than going for the assumption that the risk is low based on no information. It does produce reasonable results, and I believe the recommendations are very practical. And I do hope that it's something that will be a useful tool for some of you. We plan to have it available on our website pretty shortly. We're testing out that right now. But if you'd like to give it a try, just send me an email or give me your email address, and I will be happy to send you a link to the review version that we're working on now, because we are in the process of getting the paper published for it, but we are still seeking feedback before it goes into final production. So this being a MarFund presentation, I think a lot of us probably work in the Mesoamerican region, and I think we probably all realize that it is important to have reasonable expectations and to meet managers and other interested parties where we all are with the resources that we have on hand. And so a lot of what we talked about in the beginning, the traditional fisheries assessment methods that are sort of these black box analyses are not going to be implemented without a lot of intervention and outside intervention. And it's not going to be sustainable. It's not something that can be done year after year. So tools like this are meant to empower stakeholders and also to raise capacities. We're also always looking for ways to bring down costs and to support the development of low-cost alternatives, such as our recent study that showed that you can age cardinal snappers using just the otoliths. And I also, I do want this to be something that can be used for fishers as well. So I would so that when there are things like stakeholder meetings, fishers can come and use this toolkit and basically come with information that they have on hand, or if they want to try to do something within a fisher's cooperation or cooperative and they want to do some self-management, they might be able to get recommendations for how to go about doing something like that from something like this. And it is something that we are committed to having things that are practical and low cost alternatives. So all of our research methods, all of the methods that we use for this study to get all of this information, our sampling methods can be deployed from small boats, and we try to ensure that basically anyone can use our methods. And with that, I'd like to thank MarFund for hosting me, and we've been working with MarFund for many years, so I really appreciate them inviting me to this. All of the fishers that we work with, all of our research is conducted with fishers. I'm just the person on the boat taking the data, so they couldn't do any of that work without them, and a lot of our volunteers and research officers. My co-authors, Doctors Rachel Graham and Matthew Witt, and then to all of our funders and partners. And that's it.
Thank you so much, Ivy. Wow, what a summary of 10 years of research and work done. Excellent, excellent. Congratulations as well.
Thank you.
So we have a couple of questions, Ivy.
Okay.
I'll read them to you. We have a couple of in the chat, and if the participants wants also to raise their hand, we can have a space of dialogue as well. So we have Fabio. Fabio is asking you, Ivy, I'm wondering what are the ecological attributes that you attach to each of the species? Could it be feeding, habitat preferences, predators, competitors? The risk is for the population, but not assessing the health of the ecological community they are embedded in?
That's correct. And that is a good point. There is something, it being called an ecological risk assessment, it does automatically make you think that there must be some ecology, but no, it is based on there's a paper from 2011 from Hobday, and he kind of coined the term ecological risk assessment, and it was very much along the lines of biology and fisheries. So we do not take into account the health of the ecosystem. It is definitely something that could be applied to a different. I think that the structure of the ecological risk assessment with productivity susceptibility analysis certainly could incorporate those kinds of factors, but we didn't. One of the recommendations for conducting this type of analysis is to limit it as much as you can to information that you have that is very relevant. So if you can include more and more and more parameters if you want to, but it actually makes your overall answer a little bit more vague. If that makes sense. So we really wanted to know more on their biology and fishery rather than the health of the ecosystem. But I think it's something that would be very interesting to pursue.
Thank you, Abby. Yes, because we also have to consider the state of the chain, the traffic chain, right? So if we don't have predators, then it can also affect together with or if we have more predators, then we have higher risk with high fisheries, no? So Thanks a lot. We have also another question from Eloy Sosa. Good analysis to start, Ivy. Excellent for first look and also for identifying gaps in information knowledge about some fish resources. By the way, coastal fish, moreover deep water species, are the less studied with no regular monitoring in the MAR. So it's something that it's a tool, I think, that everyone could start using and implementing and see how things are in other countries as well. Also, Fabio's excellent presentation, by the way. also Fabio is asking, related to the question before. I'm interested in a follow-up conversation later on as I'm working with lobster and conch fisheries and ecological risks assessment. So I think that will be like a space for cooperation and working together. I don't know, Ivy, if you have shared in the presentation your email,
It doesn't
or
look
we
like it.
can write it down here in the chat.
Okay.
It would be okay to share?
Yeah. Yes, please.
Okay. And related to this, so you said that people can write to you for access for this tool,
Yes.
but you mentioned it's free and it's online. Maybe we can share where they can find it as well.
Yes, I have to find the link to
Okay,
it.
the link, but it's
Yeah.
in the MarAlliance page.
No, at the moment it's not. It's still living in Google Sheets at the moment.
Okay, okay,
Yeah.
perfect. So it's better if we write to you and you share. Okay. Then we have Surveilla is writing excellent work. It's a tool very valuable for our protected areas. Thank you so much. And I don't see any hands raised, but let me check if we have any questions in. We don't have any. Please, if you have any questions for Ivy, write down or raise your hand. And also, I think we don't have any on Facebook. I do have a couple of questions for you, Ivy, if it's possible. We still have 10 minutes.
Yes.
I think it's super interesting that you mentioned that is relevant tools, and depending on capacity among protected areas and among the different countries, it's difficult to implement, right? Have you had any close up with relevant management or MPA management in Honduras or in Belize that they are starting approaching this tool, or we are too close to mention those?
I have talked to actually fisheries managers in Puerto Rico.
Okay.
And it's managed by the U.S., but they're a very similar situation there where they don't have the funding really to do these. And so we're also in the process of trying to develop something like an ecological risk assessment, but a little bit more complicated. So I have been in touch with them, and they are looking to apply something similar. That's what we're doing now is socializing this to try to get more of the protected areas on board. And that's basically the goal for the next few months, is to socialize this tool as much as possible. Again, that's why it's not on our website yet, because we want to make sure that it is actually useful. We're including all of the things that we need to include. And I also want to, eventually I would like for this to be sort of a living document. So right now we have recommendations for 10 species, but if the structure is good, there's no reason why we can't, in the back end where it's pulling the information from, add other species in other countries, so that those things so if you are a manager and you want to go to your other users or fishers and show how why you're getting, why you have a risk assessment, or how to use this tool, that you would be able to go and actually give the recommendations so that anybody could use that. So for now, it's just based on these 10 species, but I would eventually like it to be something that is a little bit more comprehensive for different species. And we would probably need to make a separate one for the invertebrates, like the lobster and the conch, because obviously they have very different life history strategies and fisheries as well.
Different
But so far,
structure and
yes.
different indicators, right?
Yes, but so far we have been presenting it with managers. There's been a lot of interest with it, but it hasn't been implemented as yet.
Okay, perfect. It's complicated. It's also depending on data available and funds as well. So it's the first approach, as Eloy said. We have also a question from Cynthia Dias. Have you been working with scientists from ERAFMs in the region? I'm not sure what is
So regional fisheries management organizations.
Okay.
Not directly for this project. but it was an ecological risk assessment was used a similar tool and a similar method for the RFMOs for ICAT for shark species, and so that was some of the inspiration that was drawn for this.
Okay, thank you so much, Ivy. Also, as you said, you've been working with fishers since the last 10 years. Do you know, have you been talking with the fishers about their view and how do they see the fisheries, and how do they see this kind of tool? What's
Yes. So the fishers here in Honduras are they're fairly pessimistic, I have to say, kind of overall about the status of all fisheries. There's a lot of feeling that they don't have any support, and actually something that's surprising coming from a background of fisheries management in the United States, where the fishers want everybody wants hands off. They want to be able to do everything on their own. Everybody, and not just in Honduras, but in other areas, they would like management of some kind. And most of that comes from wanting, they want enforcement to keep illegal and unregulated fishing from happening. So there's a lot of transboundary fishing that happens, and fishers from all countries are concerned about this. The fishers in Belize obviously are a little bit more optimistic about the fishery because it is young and they see these big fish. So I think that is something that they're all very surprised when they learn about the life history and how old these fish are and how vulnerable that they can be to overfishing. But overall, the fishers in the areas where they're already overfished are not surprised by these results. And but the fishers who are younger or who don't have as much experience, or who are in areas where the fishery is still doing okay, they're very surprised by a lot of the results that we're getting. So yes, I think it's important. I think it's something that can happen. This fishery, these are old fish, and I mentioned they don't have anywhere to go to escape the fishery. So this fishery can collapse very quickly, and I think it's something that managers really need to take into account, especially because there's a lot of interest in the deep sea fishery in Belize.
Yes, thank you. I think it's very, very, very important that they know how is the situation, because it affects them directly, and making them know and making them aware and making them participating in this kind of efforts is also empowering them on their fisheries and on their resources that they live from. So that's really nice that you had the time and you had the space with them to talk about this. I think we have 5 minutes more. I don't know if you have any other questions, or you want to mention something else, Ivy, but we would like to thank everyone to participate in the webinar. And please, if you have a few minutes, I think it takes 2 minutes to fill our feedback survey before you leave. That will be very much appreciated, as well as following us in our social medias to share the work that MarFund and now MarAlliance in this case is implementing. So thank you so much, Ivy. I think we can, oh, I have one more question. No, we don't have any more questions. Thank you.
Yeah, I put
To
my
all
email
the
address in the chat.
Yes,
So if anyone wants to reach out, I'll be happy to answer more
yes.
questions or send them.
Yes, thank you, Ivy. We have your email, and then we'll put the recording of this webinar as well in the MarFund webpage, so we can also share some of the documents that you have mentioned during the presentation. I think I have one more that we have the time. You mentioned that all those species are living in a very limited habitat, and most of them are among 100 and 500 meters deep depth of depth. Um, all those areas that you mentioned across the coast, are those protected area, or most of the narrow and deep waters are not protected?
Correct. Most of them are not within um, the protected areas. There are a few, like, well, Turnef, a lot of that area would be within the Turnef marine protected area. However, there aren't any specific restrictions for deep water fisheries. Within other areas like the Half Moon Key, the closed area at Glover's Reef, there are very small no take zones that would overlap with the deep water species, but it's pretty small. But having conducted some research within those small protected areas, the ones that are very well enforced, such as around Half Moon Key, there are more fish in those areas. So even I think some small but very well implemented marine protected areas can protect population, because even though they're deep and there's not really a lot of water movement down there, the larvae move around when they spawn. And so by protecting one area that where it's important for, say, spawning or for the bigger animals to continue to survive, that can have a lot of positive effects for the entire population that is fished. So even small protected areas that are well enforced can have a lot of benefit.
That's where I was going. I
Yeah.
think it's super nice that you read my mind.
Yeah.
Uh, it's fantastic. It's fantastic that we can make this recommendation, and everyone in the region can try to apply this tool and see how the fisheries are going and how the stocks of commercial fish population are rising or decreasing. So it's so nice that we have now these tools that we can use and share with all stakeholders. Thank you so much, Ivy. So
Thank
I
you.
think we can end this presentation. Really appreciate your time, Ivy, and all the work done with the project and also through the years. And thanks all the participants that we have today. So please keep connected, and we will inform you on next webinars and next events at Marfon. Thank you so much.